everyone, and thank you for joining us today for the third installment in our Technology Horizons webinar series. Before we begin, I'd like to acknowledge that at the University of Waterloo, much of our work takes place on the traditional territory of the neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land promised to the Six Nations that includes 10 kilometers on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building. There are a few logistical items that I'd like to cover. First of all, we're sorry for starting a little bit late. We had some audio issues, as you might have noticed at the beginning. You also may have noticed that we're recording today's session. If you'd like to watch it again or share it with colleagues, the recording will be made available to all registrants in the next few days. We're also going to have a lengthy Q&A session at the end of today's session. So if you have questions that come up during the presentation, please add them to the questions pane. To those of you who submitted questions ahead of time, thank you so much for sharing those with us. We'll try to cover as many questions as we can in the time that we have. I'm Karina Graff, Associate Director of Marketing and Digital Sales at WattSpeed here at the University of Waterloo. If you're not already familiar with WattSpeed, we are a new unit at the university created specifically to help professionals, organizations, and executives keep pace through disruption with education focused on technology and business that's designed and delivered by our faculty and trusted partners. These days, technology and disruption is often rooted in emerging technologies like AI, and that is why we're all here today. So I'd now like to introduce our moderator and speaker. Our moderator is Dr. Joelle Blitt. Joelle is a professor of economics, chair of the Council on Innovation Policy at the University of Waterloo, and a senior fellow at the Center for International Governance Innovation. His main research interests are the economics of innovation and innovation policy. He studies, among other things, the diffusion of disruptive technologies and their impact on productivity and jobs. You'll see Joelle a bit later during the Q&A portion of the webinar. Our speaker today is Dr. Alexander Wong. Alex is a professor of engineering and the Canada Research Chair in Artificial Intelligence and Medical Imaging, and the co-director of the Vision and Image Processing Lab at the University of Waterloo. He is also the chief scientist and co-founder of Darwin AI, a leading-edge AI company that is backed by more than $17 million in venture funding. Alex, over to you.
Thank you very much. So today I'll be talking primarily about trust in AI. So first I'm going to talk a bit about the rise in AI and machine learning, especially related to generative AI. We'll kind of talk about some of the challenges, both from a regulatory and trust and accountability perspective, with leveraging AI in in our regular everyday lives and in our businesses. I'll kind of briefly talk about what does explainability mean in AI? Why is it important? I'll talk about what trust is in AI, why that's important with a number of different use cases and examples, as well as talk about some of the best practices for deploying trusted AI solutions. So first of all, recent success in artificial intelligence and machine learning has really led to an increase in the interest as well as success for using AI to tackle different real-world applications across different sectors, from the internet, healthcare, manufacturing, transportation, aggregation, financial services, creative services, so on and so forth. And in many cases, in many areas, AI and machine learning is already a ubiquitous part of our lives that we don't even think about. For example, every time you pull your phone to send a text message and it auto-completes for it, that's AI. Anytime you're writing an email and it predicts what you're going to write next, that's AI. Anytime you take a phone out to take a picture, you're actually using AI to deliver really great pictures. And more recently, there's been this epic rise as well as hype around the notion of generative AI, which is a form of AI where the AI actually creates new media, new content, be it images, text, audio, video, and so on and so forth. So an example on the left-hand side is a really cool generative AI model that given a text description, in this case, modern outfits inspired by Van Gogh, Monet, and so on and so forth, fashion photo shoot is able to generate a photorealistic image of a model wearing something inspired by that style. On the right-hand side is a very interesting case where text, an entire article, was actually written by AI itself, and nobody knew because at first it was posted as a self-help article. People really found it to be inspiring, and then later on the author actually revealed that this was all written by a generative AI. So there is some reason to the madness, right? And right now, different corporations, industry is now looking for different ways to really adapt and incorporate AI, especially generative AI, to give them the competitive edge. So this sounds great and all, then the question here is why don't we all use AI all the time by now? And based on just interactions with numerous collaborations with different enterprises in both regulatory as well as mission critical sectors, such as automotive, transportation, aerospace, healthcare, finance, and so on and so forth, the message from industry is very clear. AI, especially deep learning, is game-changing, but full of challenges to widespread adoption across industries in reality. So there's this challenge, this barrier going from translation, from promise to impact. And two of the biggest challenges with leveraging AI in real-world practice, which I'll be really focusing on here, is trust and accountability. So on the right-hand side, you see an example where AI was found to actually show a particular bias against people with disabilities. And also in recent years, an AI system that was used to determine and predict and recommend whether somebody should get healthcare or not was actually pulled and found to be very biased against African Americans because historically they receive less care and less money and funding, right? And so this becomes a really big issue that we really need to tackle, especially with the proliferation of AI coming soon, right? Especially in the face of massive misinformation and criminal use of artificial intelligence. So recently there was a case where somebody actually was sentenced to jail because they were using AI to generate child pornography. In another case, they were actually using AI to train and learn a child's voice and using that to scam their parents in a fake kidnapping. And of course, we've also recently seen different election campaigns generate using AI, generative AI, that were not exactly in the best light. So even personally, I tried, hey, what if I actually ask it, why am I one of the best violinists in the world? It gave me this great, wonderful, elaborate story that says, I have exceptional technique and musicianship. I've won lots of awards. I go around on tours. I don't play the violin, right? And so it's able to really confidently tell me this really great life story for a life I didn't live. And of course, there's also legal ramifications that we need to think about. So for example, recently, Getty Images was suing a generative AI company because they used their images to train their generative AI model to create images. And so in many situations, sometimes when you're using it to generate images, it has the word Getty, the actual watermark directly embedded in it. And of course, there's been a number of different lawsuits claiming that generative AI was used to train on code that they don't have access or right license to, and using that to help people generate code. And so these are all very big concerns that we need to think from a legal perspective. And so right now, there's been a growing public mistrust in AI, right? Ranging from chatbots saying inflammatory comments, it's taking all our jobs and so on and so forth. So now it's because of the way AI has been released in the wild, now these have become bigger concerns. And so trust in AI has now become a bigger and bigger topic as we go. And before, a lot of companies were thinking, okay, I will worry about it and we'll wait and see. I'll worry about it when the problem arises. But now with regulatory consequences, it's no longer about waiting and seeing, right? For example, in Canada, we have the Canadian Digital Charter, in particular C27, which covers algorithmic transparency. We have the European Commission's AIA Act, the Artificial Intelligence Act, where algorithmic transparency is a very big part, and you can have fines up to 30 million euros or 6% of global revenue. So from a financial perspective, the consequences are quite big. More recently, the FTC in the US has said that hold yourself accountable or be ready for the FTC to do it for you. So it's no longer about waiting and seeing. Compliance is now a global must, and the need for explainable AI has grown as a result. And so a lot of people usually think about trustworthy and transparent AI when they're actually thinking about it, more as a reactive means to avoid consequences. But what I believe in is that there's a strong business case for trustworthy and transparent AI, that we should view it as a proactive means of gaining competitive advantage, right? So for example, beyond accountability, explainability and trust assessment can lead to enhanced product quality through the identification of gaps and problems in the AI to improve it during the production cycle, right? It helps increase customer satisfaction as well as retainment, and also mitigates a lot of the branding risks associated with AI behaving poorly. Just the PR nightmare becomes a big issue, right? It helps improve talent recruitment and retention. There's been a growing trend of employees really wanting to understand and having concerns about employers' ethics, culture, and public image. And so having trustworthy and transparent AI really helps with this. And last but not least, it has a lot of added value for customers and clients in the face of increasing AI regulation, right? So when you have trustworthy and transparent AI solutions, your clients can be rest assured that they're able to leverage it in a responsible way. So how do we actually move towards there? There are several key steps towards more trustworthy and transparent AI. The first being just the first easy steps is guidelines, principles, and checklists. So it's a great starting point, but oftentimes it's insufficient. So you know what are guiding principles, but how do you implement upon it? And that's where explainability and trust assessment and best practices really come in. So with explainability, what we're trying to say, why did the AI make a particular decision? Where are the biases and gaps in fairness? In terms of trust assessment, how much can we trust the AI, as well as when can we actually trust the AI? And last but not least, with best practices and ethical considerations, is how should I design and validate trustworthy AI in a way that allows for more rapid deployment? So the first thing we're going to talk about is what is explainability in AI? So a lot of times in our today AI systems, we have training data. A machine learning process uses this training data and to learn some kind of learned function or model, right? And then a decision or recommendation is then given to the user based on the task at hand. Very simple. The problem here is we really don't know why the AI did things a certain way. Why did it make a certain recommendation? Why did it not recommend something else? When does it succeed? When does it fail? When can I trust this AI? And how do I correct the errors that the AI exhibit? With explainable AI, which we often call XAI, you have training data. You still have a machine learning training process to create a model, but what you're creating is an explainable model with an explainable interface that allows interaction with the user for a given task. So with explainability in AI, you understand why the AI made a certain decision, why it didn't make another decision, know when it succeeds, know when it fails, and know when you could trust it, and know why it made an error. And these are very critical. And so why are they critical? Right? The first thing is explainability allows us to ensure that the right decisions are made for the right reasons. So some examples in the manufacturing space, right? With explainability, what you see is highlighted, right? You have visual indicators used by the model to make predictions on visual parts inspection. So we say a particular part is actually defective, but here we're showing it thinks it's defective because of these particular areas. For example, with the screw, there's actually a fraying on the screw. On the wires, it shows that the reason it said this was defective was the wires are fraying, right? On the right-hand side, in a clinical situation, it shows the relevant visual indicators in the lung, in this case, right, on why the model actually made a prediction that they have severe lung disease severity. So here you see highlighted, the reason they think it's actually severe lung disease is because of ground glass opacities, honeycombing patterns. So this gives you a much better sense into whether or not it's actually making the right decisions for the right reasons, right? Another very useful use for explainability is to identify reasons behind wrong decisions. So we know when it's right, that it's making the right choices, right rationale. Here, we want to know why it makes a mistake. So on the example on the bottom left, what you see is the model thinks the pedestrian is a cyclist, and if you see highlighted, it's because they're overlapping on a bike. right? And so as a result, the rationale this model actually made a mistake was that person overlapping bike is equal to cyclist, right? This gives insight on how to fix it. In the middle case, it shows that the model is able to identify all of the pedestrians, but none of them had any human annotations, right? And this is a great case where it shows that you're only as good as your data. And so here what you see is that because none of the people were annotated, because some human error, the model is right, the data is wrong, and the model tries to learn from the data to improve itself, when in fact learning from faulty data actually makes it worse. And last but not least, on the right-hand side, here in the clinical case, we show that the model is actually providing a misdiagnosis on a chest x-ray by never looking at the person's chest, never looking at the person, but looking at the embedded text. And so identifying where it screws up and why it screws up allows you to fix that problem very easily. Last but not least, right? Explainability is very crucial because it helps you identify when right decisions are made for all the wrong reasons. We often look at the number, right? Accuracy, sensitivity, specificity, but we don't really know whether it's actually making the right choice because of the right rationale. On the bottom left hand, what you see is a self-driving car model that does extremely well, very, very accurate. But what we found by using explainability was that it never looks at the roads, never looks at the street signs, never follows any rules, and it just looks for obstacles as highlighted here and tries to steer away from it. It's like playing reverse bumper cars. Would you buy a car based on this type of decision-making rationale? Probably not. In the middle case is an AI model that was trained to detect COVID-19, right? Again, very, very great accuracy, sensitivity, and so on and so forth. But when we analyze it using explainability, what you see highlighted there is that it never looks at the body, never looks at the lungs. It always looks at the bed that the patient was lying on, creating this spurious correlation with inherent biases. So it makes all the right decisions for all the wrong reasons, right? And so if we were to look at explainability from a generative AI perspective, right, which is more of a recent development, it becomes even more important than ever. So an example in this use case, we audited the behavior of a large language model to build explainable and trustworthy generative AI systems. So for example, here, by looking at what's highlighted and the association, we're able to check if the decision was actually made for the right reason. So it's able to associate numbness, confused, trouble speaking with stroke for all the same reasons of numbness, facial problems, confusion, difficulty speaking, so on and so forth. So we're able to identify that it is, in fact, making the right decision and generating the right text for the right reason. Here we have another example where we're able to then see if the correct relationships are actually driving the thought process. So here I'm asking about, I'm saying a cat is bigger than a mouse, right? Who is bigger, Tom and Jerry? I never told it who Tom or Jerry is, right? But it's able to associate Tom and Jerry with cat and mouse, thanks to the popular cartoon, and it's able to identify the relationships to see if it made the right decisions. And not only that, you'll see a certain part question is actually completely ignored because it's related to completely irrelevant information, right? So since it's here is some useless information that has nothing to do with anything, right? Nothing to do with size. And so it's able to ignore it when making the right decision because you don't want it to use useless information in making the right decision, right? Similar here, we're able to check if the correct rationale is actually used to drive the actual thought process. So here we ask, Sam loves playing the violin, cries every time he plays the violin. Does Sam like the violin, right? And so here, by looking at the logic here and the highlight words, we're able to associate that he does cry, but that's because he's emotionally invested and enjoys it, and that's the rationale for crying. And so here, it's generating text based on the right rationale and thought processes. So that's on explainability. What about trust? So a lot of times we ask, what does trust actually mean in AI? So a lot of times what we do is we draw from social and behavioral sciences to consider what is trustworthy. And in our particular case, the way we define trust is based around the notion of overconfidence and overcautiousness. So when something's overconfident, they'll say, this is it, with a very high confidence, even though it's completely wrong. In terms of overcautiousness, it's even if it has the right answer, it's very hesitant. Say, maybe that might be right, maybe it's not. And in both of these cases, can't really trust the decisions. And so by combining this, we're able to have something called a trust score that measures how confident the AI is in its decision, taking into account both correct and incorrect predictions. So a system or decision that has low trust is one where either the confidence is low when it's correct, or confidence is high when it's incorrect. You get a high trust score when the confidence is high, when it's correct, and confidence is low when it's incorrect. This gives you a much better sense on whether or not the AI's recommendations, predictions can be trusted or not, right? And an example of why trust is crucial, here's an example of a predicting for a default risk, right, at the system level. So what we see is system level performance is okay, 70%, but we want to dig deeper. We want to look at the system level feature impact, because this allows us to dig out what exactly are the driving factors. So for example, some of these driving factors are based on transactions, which makes sense, but the sixth most important factor was actually gender, which is an inherent issue. And by looking deeper into it, we can actually look at the system level trust, whether or not that is an issue. So in this case, when we look deeper into system level trust, the trustworthiness of answers for both males and females are actually around equal, right? So we're able to figure, okay, it is kind of used as a factor, but it's not actually having huge influence on either of male or female. But when we look at age, it actually makes a much bigger difference. So the AI was actually giving less trustworthy answers for individuals who were over 50, right? And equally, for education, it was actually giving less trustworthy results for individuals with high school education compared to university, grad school, and so on and so forth. And these are the types of insights that allow us to dig deeper into when we could trust the model, when we can't, and where are the areas and gaps that we want to improve upon, right? And then we dig deeper into prediction level governance, where for each individual decision, we're able to get at the source. It made this decision because of these particular highlighted factors. And as a result, it predicts the client defaults with 86% certainty. Because if I rely on any other factor, it's going to have a no default decision with only 31% certainty. And it's these kind of things that allows you to know and understand not only your model better, but also your data. And so last but not least, let's talk about some of the best practices for developing trustworthy AI. So first of all, really understand where the AI can improve your business. Don't just do it for the sake of doing it or for a nice press release, right? That usually doesn't get you too far, right? You might have some good initial success, but as you go, it ends up being a solution that you are unlikely to deploy. Make sure that you retailer for a specific use case and don't use as is and use your domain data, right? There's a lot of jack of all trades AI models out there, but they're master of none, particularly in your specific business. So really leveraging your domain expertise and your data to really drive better models. Be sure that you plan the resources appropriately. So the amount of compute resources, human resources, data resources, and so on and so forth, because a lot of times we think, okay, let's just build a model. What's actually required to build a model is actually a lot more complex beyond just a couple of computers. Quality data is king. Having great data goes a long way to building better systems, right? So data where you try your best to mitigate your data biases, making sure you have good data balance, good data diversity. Perfectly balanced data doesn't necessarily mean you have the right diversity, right? Good quality data, right? As well as understand where your data comes from, right? For example, the copyright, do you even have permission to train with that kind of data? Make sure you add the appropriate safeguards related to your business at hand. You really don't want an AI solution that goes off the rails, doing things that you cannot predict. So that's where understanding what type of safeguards you would actually like to impose on your AI model becomes very crucial, especially when it's client-facing, right? Make sure you audit your solutions thoroughly. Make sure you have a clear understanding around it. Leverage AI explainability and trust quantification where possible to get a much deeper understanding in both the quality of your data and your model and how they behave, right? Take privacy considerations really into mind, right? Are we using an API, right? Where does the customer data go, right? Is it protected? Where does our company data go? Does it all go to cloud? Does it go to a third-party cloud? Becomes very important when you're building these kind of AI solutions. Really take responsible AI practices to heart, right from the start. From the data collection process to the training process, all the way to the audit and deployment, make sure you think from a responsible AI kind of mind frame. Have reasonable expectations, right? Don't expect it to give you something null and perfect and magical on everything it does, right? It might not be best at start, but you could improve it over time. Start small with controlled pilots before going with massive deployment. You don't really want a rogue AI to run wild. And of course, monitor closely and iterate often, right? So some final thoughts, right? AI holds tremendous promise and potential for numerous sectors and facets of life. There's tremendous challenges to achieving trustworthy AI, but there are key steps that you could take to improve much better solutions. And in general, the benefits really outweigh the challenges in designing and operationalizing trustworthy AI solutions. Thank you very much.
Okay, well, thank you, Alex. That was an absolutely amazing talk. I know I learned a lot.
Thank you.
And I'm sure that all of you in the audience as well, whether you're an industry leader, a policy leader, or just an engaged citizen, I'm sure you found lots of interesting questions that Alex's talk posed. So we're gonna try and address some of those questions a little bit more. We're gonna try and delve a little bit more deeply. We received lots of questions from you, the audience, ahead of time. And we're not going to have time to go through all of them, but what I've tried to do is basically extract some of the main themes in these questions. And so I'm going to ask Alex about some of these main topics. And we're going to leave 10 minutes, something like that at the end to address questions that are coming in real time. So make sure that you do submit any questions that you have at this point as well. Okay, so Alex, I wanted to start with, I think something that was central in your talk, which is trust, and the idea that just making a prediction is maybe not enough for these models, right? At least for many applications. You also want to get a sense of how certain they are.
Yep, that's exactly it. And so that's the way we define trust based on, I guess, the social science and I guess behavioral science, where trust is not just about the decision being made, but how confident you're about your decision. So for example, we treat something as trustworthy when it's confident, when it's correct in terms of what it's telling you, as well as when it's not correct, then it will actually be a lot more hesitant and not show as much confidence, because this allows us as humans, through human-machine interaction, to be able to much better understand when I could leverage my own expertise versus listening to AI.
Right. Okay. And so it will depend as well very much on the application, right?
That's exactly it. So for example, in a medical case, right, when it's leveraged for clinical decision support, for helping support doctors in making decisions, when an AI is confident and says, hey, I believe this person has a certain condition and that you should look at it, and I'm quite confident about it, then the doctor can much trust it and say, okay, the AI is quite confident, I really should dig deeper into this. Versus if the AI said, maybe I'm not quite sure, but maybe this patient has something you might look into, then you might use your own best judgment in making your clinical diagnosis.
Okay, very good, thanks. We also got questions around bias, and bias obviously is something we often talk about. It's something that, as humans, fairness is something that is ingrained in us. We both have 7-year-old kids, and we know that they're always about, fairness. And so for you, how do you define bias? What does bias mean? And for example, if young men pay more on their car insurance, is that because there's a bias in the system, or is that, because the data suggests that they have accidents at higher rates?
That's actually a very good question. So for me, there's many different, perspectives on what bias is. For me, biases are situations where it results in a negative, tendency towards certain groups due to not actual key factors, but due to things like spurious correlations and so on and so forth. So in the example he gave, in terms of, insurance predictions, for young men, in situations where it's data-driven, where the individual decisions for insurance for individuals, whether they're male or female, are based on key factors, right? And if it so happens that for these individuals and they're male, that they have a tendency to have higher accident rates, and as a result, receive higher insurance, I would not consider that as a bias. Whereas if we were to, for example, use explainability to really understand the AI model, and the AI model is saying, this individual should have higher insurance rate, because the defining factor, or one of the defining factors, is the fact that they're male, that is a bias that we always like to try to mitigate.
Okay. Do you think that we're holding our algorithms at to too high a standard? And so the reason why I asked this is, so last week I was speaking with someone fairly senior in government, and they said one of the big reasons why the government isn't adopting these algorithms quickly is there's a view that they're biased. And that they simply can't adopt something that has some bias in it. But on the flip side, there are many situations where we're making biased decisions in the real world. For example, around hiring, we know that hiring managers are not always objective. And so would an algorithm that at least is less biased be something we'd want to be adopting?
Yeah, it's my opinion that the answer is yes for this particular case, mainly because, again, it's my belief that no AI algorithm is always going to be perfectly unbiased. That's just not reality. You cannot create a system like that. But if it actually helps minimize and reduce biases and provides a very good, performance and functionality, then these are systems that are worth deploying. That said, I do believe that we should hold AI to a higher bar than ourselves, because for me, one of the inherent, goals or objectives of creating AI is to help us be better from a human-machine collaborative perspective. And so hold them to a higher bar of standards means that they would be much more capable of helping us in improving our own decisions and predictions.
I think that's absolutely fair. And I think the other thing, that I worry about is people can change on the fly and hopefully fix their biases as they go. But an algorithm is, can be a bit more static.
Exactly.
Sounds good. Okay, so you talked about trust, you talked about explainability. I think we can all agree those are great things. But is there a trade-off? Like, should we be worried that when we start designing a system where this is central, the system might be lesser in terms of accuracy, prediction accuracy, maybe it'll cost more? Like, what are the sorts of trade-offs?
Yeah, very good question. So traditionally, there's always been a kind of like a fundamental trade-off between performance and explainability or transparency, where simpler models they don't perform as well, but inherently because they're simpler, it's easier to interpret. Whereas nowadays with the large language models with billions of different parameters all interacting together, they're extremely powerful. They can do much better than these simpler models, but it becomes much harder to actually understand how their thought process goes on. That said, there's been huge advances in the field on explainability, especially for deep learning, for large scale models, like I just demonstrated in the presentation. And leveraging those tools allows us to kind of get the best of both worlds, where not only do you get the power of these large models, but you also have the outer explainability, so you understand the thought process, rationale on when it makes the right decision, when it falters, and so on and so forth. So it gives you now not only a powerful model, but one that you could more trust compared to before.
Okay, very good. Okay, so let me shift a little bit. So a few people asked about hallucinations, and obviously every time we talk about large language models, everyone talks about hallucinations. And it turns out that I didn't know that I have a master's in computer science from Stanford. At least until I checked ChatGPT.
Congratulations!
Thank you. It was really easy to get, actually. So what is what's the state of the art there? Can we expect significant improvements in the short run in terms of making sure that these algorithms don't have hallucinations? And how quickly can we expect to see this?
Yeah, so there's been a lot of research advances and progress in this area to reduce the number of hallucinations, ranging from improving your data sources, training in a certain way. So there's been a lot of progress. But I think myself and a lot of academics, we kind of believe that there's no way to perfectly remove all hallucinations. We can do our best, but you're never getting a perfect system with no hallucinations. Because if you just think about it, even us as humans, a lot of times when we're answering questions, how much of that is completely factual versus what we think is correct in our head, when in fact it might not be. Even for us, it's very difficult to check those, do those checks and balances. So I could see it improving, and even improving significantly over the short term, but it's never going to go away completely. And so that's why I mentioned some of the best practices that companies should employ, such that even in a situation where it might hallucinate, that you have the proper safeguards that these hallucinations do not affect your clients, do not affect your industry, and do not affect society as much.
Okay, and maybe you already answered it, but one of the questions that Bob submitted ahead of time was, what can companies and individuals do today to try and address this? Do you have any additional thoughts, or you think you?
Yeah, no, I think the key thing is to really understand what you're using it for, and the approach, and then you'll be able to devise the appropriate safeguards around it, so that you're less likely to be influenced by hallucinations, incorrect answers, and so on and so forth. And that's where really having the domain expertise to really guide your AI models towards the right path. Because at the end of the day, you know your customers the best, your AI model doesn't, and figuring out what are the ways to channel it so that you get the most impact on your customers and clients without creating, I guess, negative impacts such as hallucinations become quite important. Okay, very good. Okay, so let me ask you maybe a slightly more personal question, and this is a question that comes from David. You're an engineer, you've developed many of these models, you have a startup, and you've spoken very eloquently about how we need to think about trust and have responsible innovation. And his question is very specific. It just says, I'm an engineer. What can I do in my daily work to make sure that I'm innovating around AI responsibly? Yep. So as an engineer, the way to really innovate around AI responsibly is to really understand each of the individual steps necessary to create, validate, and deploy your AI so that you can ensure that it's behaving in a way that you feel comfortable with. So from a data perspective, don't just look at your performance numbers. That 99% might not really be the most meaningful when it's making all the right decisions for the wrong reason. Really understand your data, look at your data, not just your numbers, right? Really understand the associated tasks it's for. Make sure that from a validation perspective that you take the proper checks and balances of, not only just checking general performance, but look at explanations. Is it performing in the right way? Is it performing in a trustworthy way under different situations? Understand its limitations so you could improve it over time, as well as put safeguards so that in situations where it's not trustworthy, don't leverage it, or at least have a nice warning. And last but not least, which is very important, I like to emphasize, is as an engineer, look and continue to monitor your AI models and systems as it's deployed in the wild. What might look great in a sandbox, as we know as engineers, might not look so great when deployed in the wild. So understanding, getting customer feedback, understanding how your models perform in the wild, and looking for red flags or yellow flags on when it's not performing so well, so that you can use that information to improve your system becomes quite key.
Okay. Well, if I can ask you one last question, what keeps you up at night? And specifically, does this keep you up? Do you worry that AI is going to get so smart that it is basically going to displace us?
So that's not one of my worries, mainly because I'm a huge proponent of human-machine collaboration, and I firmly believe AI, generative AI, and so on and so forth, to be core part in helping us improve what we can do. So can it help us do better? I think it can. Can it allow us to do more things, to scale bigger? I believe it can. Can it help improve our consistency in making our judgments, performance, and so on and so forth? And I also feel that there's a lot of different mundane tasks in our daily lives where we could really benefit from having an AI to help us with, some of them, so that we can actually focus on things that are more creative, things that require more complex judgment that might affect, ourselves, our family, and all those around us in society. So I am much less worried about that. What does worry me is in situations where AI is released into the wild and people using it for purposes it's not intended for. And that's where I'm actually glad to see a lot of the AI regulations as well as best practices and are now being actually taught at schools and being enforced in governments through policies and so on and so forth.
Yeah, I mean, essentially, it's a tool, and like any other tool, it can be used for good or nefarious purposes.
Exactly.
Yeah. Okay, excellent. So I see that we have a bit less than 10 minutes left, and so I thought we'd switch gears a little bit and go directly to the questions that you have been posing live as we've been chatting here. And so the first question from our audience is the full assessment and control of AI trustworthiness something to be vetted at the development and regulation levels before deployment? Or is it something that can happen at the user level, like they are expecting with ChatGPT currently?
Okay, that's actually a very good question. I believe that this type of, I guess, things should be vetted both at the development level, as well as the regulatory level, as well as the user level. And the reason for this is that each of them have actually very different perspectives from a trustworthiness perspective, and using that information to guide the development and improvement of the system becomes quite important.
Okay, very good. I hope that that helped. So our second question is, can you expand on domain data and how a company can use AI for internal purposes without the AI provider taking the client's data and results?
So that's a very good question. Now, it really depends on how you want to actually build your AI solutions. So from a lot of experience, I know companies as well as recommendations where this domain data is actually kept all in-house in kind of either their own servers or private cloud and used to build their own internal solutions to help their employees, clients, and so on and so forth. There are also ones where they're employing third-party systems, and that's where really understanding where the data sits becomes quite important. For example, there are now proliferation of APIs where the data really is in a encrypted state where both the company as well as the provider don't have direct access to it, and so that helps. But it's definitely a very important concern, especially when you have confidential or for individuals in I guess like mission critical or even government types of institutes. Understanding where the data lies and who has access to it becomes actually very important.
And again, I was speaking to some government folks last week, and that's exactly what they were saying. I'd love to use ChatGPT for my work, but most of what I work with, I just cannot put in there because it is confidential.
That's exactly it. And so a lot of times now they're developing these private cloud kind of solutions where everything is deployed on their own server or their own cloud. So that the third party doesn't really have full access to it. But there's always, again, fundamental trade-off on how much work you want to do versus how much you would actually like to license and source.
Exactly. And I said to him, well, you can build your own system.
That's
which
right.
Obviously is very expensive.
That's exactly it.
Yeah. All right, very good. So our third question is use the example of credit ratings, et cetera, for the model and explainability. Is it your thought that consumers, through the advances of AI in these models, will be in a position to demand explainable reasons from retailers, financial institutions? Yeah.
The answer is yes. And for me, it is not even just from my own perspective or my own position. Right now in Canada, especially in the European Union, there are actually rules and regulations for algorithmic transparency where individuals have the right to actually question and ask what is the rationale and thoughts behind a decision being made by AI. So for example, if an AI system is used for determining immigration, right, whether somebody should receive immigration status, right, an individual has the right to ask, if they got rejected, hey, why was I rejected? Why did I not receive immigration status? And so this is actually going to slowly become the norm and something that we really should be aware of. And it's going to happen to every AI system. So anyone deploying AI, especially in these kind of critical situations, really need to start thinking about algorithmic transparency.
Right. Which is something, of course, before machine learning we had. I'm thinking about my simple regression model.
Yes,
it always tells me why we predict a certain thing or something.
Exactly. Now it's become more complex, but now the tools are catching up to be able to get explanations around them.
Exactly. Excellent. Okay, so we have another question that asks, what technologies can be leveraged to govern AI systems and increase public trust in AI? So how transparent should AI systems be in terms of sharing APIs with the public?
Yeah, that's a good question. So for the very first part is there actually is a number of different technologies out there for auditing, for trust assessment, for explainable AI and so forth that can then be leveraged for this specific purpose. In terms of transparency, in terms of sharing APIs with the public, that's always going to be a very contentious topic because there's always the trade-off of public transparency versus competitive advantage. Right now, that's still something I'm a believer in APIs that should at least provide a certain level of openness in terms of its functionality. I'm also cognizant and also understand the fact that companies cannot just release all their algorithms or the proprietary work because that's part of what makes their business. So having a nice balance between open APIs that might not necessarily provide full transparency on how they work, but in terms of the general functionality, I think that would be a good trade-off.
Okay. Very good. We might have time for one, maybe two more questions. What technologies can be leveraged to govern AI systems and increase public trust? Sorry, this is the one we just tackled, isn't it? So you mentioned as one of the best practices for trustworthy AI, adding appropriate safeguards. Can you give a few quick examples of great starting safeguards to incorporate?
Sure. A very good example is suppose you're using generative AI to create chatbot assistants, right? So a very easy and common safeguard people incorporate is rather than just, I mean, they try to train the model best not to say things that are offensive, but there's also safeguards like filters and queries on, what kind of questions can be asked. Right? If it's suppose you're creating a banking assistant, right? You probably don't want them to answer questions about movies, about politics, and so on and so forth. So you can actually add these additional safeguards. So when it sees these kind of queries, that it will not actually respond to them in an inappropriate manner, or sometimes if at all. Right? It say, sorry, this is an inappropriate question. I just cannot answer that. Please ask me something about, your bank account and so on and so forth. And another way, and vice versa, you could also do a lot of safeguards in terms of filtering what actually gets produced. So if you check that the AI is producing certain keywords, certain phrases that are just inappropriate for your particular domain, you could also equally filter that and just say, I'm not sure, I cannot answer this particular question. Please ask me another question. So these are just some of the basic safeguards. There's also a lot of other safeguards that you can impose, but even some simple heuristic and rules to kind of take human intuition and human knowledge and business practices and incorporate directly into your models to guide what they say and what they don't say and how they say it becomes quite important for building trustworthy as well as just better systems in general.
Okay. So we're almost out of time, but I just want to squeeze in one last one, and especially because he says, thanks for the interesting talk, which is exactly what I was going to say. But he or she asks, what are your thoughts about synthetic data in the context of trustworthy AI or improving the quality of original data sets?
Yeah, so I'm actually a very big proponent of synthetic data. And the reason for this is there are many situations where synthetic data is really the only source of data you can even use or train on. A example that I always like to give is on EMR data, so electronic medical records. These are very hard to come by. And even if you have access to it, there's a lot of different rules and policies, and rightly so, right? There's confidential information about patients. So there's patient confidential and so on and so forth. You don't just want to open up all that data to the world. Sure. On the other hand, there's been a big movement towards using algorithms to take this confidential data and really learn and understand it and generate synthetic data that can then be used to build better models, that can be used to get better statistics, to get a better understanding of your patients as well as hospital system. So for me, synthetic data, when used in that way, is actually what I would consider as using essentially generative AI for good.
Okay, very good. All right, so they're going to yank us off the stage. So unfortunately, I am going to have to shut this down. It was super interesting. I learned a ton. So thank you very much, Alex.
Thank you very much.
And we're going to pass it over to Karina. Thank you.
Thanks very much, Alex and Joel. That was a fantastic session. I loved. The next event in our Tech Horizons webinar series is called Your Technology Radar. Are you quantum ready? Featuring Dr. Michele Mosca. We also have upcoming an executive sprint called ChatGPT and the Large Language Model Revolution, which starts September 28th. And finally, our Tech Horizons Executive Forum. It's a one-day event designed for senior leaders happening this November in Toronto. Details for all three of these sessions will appear on screen after I wrap up. We'll also send you an email with more information. Once again, thank you to everyone for joining us. I hope you have a great day.